My name is Catherine Passman, and I've figured out 2 new ways to assemble Sonobe Origami units. This is a rhombicosted dodecahedron. It has 12 pentagonal faces, 1 shown here in orange, 20 triangular faces, shown here in blue, and 30 square faces, shown here in red. I wanted to figure out how to make this out of origami. One really common mode of origami is called a Sonobe unit. A Sonobe unit works like this. If you have 2 pieces, you take the triangular flap from one and you put it into the triangular pocket in the center of the face of the other. Now, it's commonly known that Sonobe units can be used to make triangles, like this, and pentagons, like this, and those are 2 of the types of faces in our rhombicosted dodecahedron. The struggle came when I tried to figure out how to use Sonobe units to make a square. I eventually figured out that if instead of doing the final fold, like this, you left it flat, you could assemble the 4 Sonobe units to make a square like this. As a result, I had a way to make all of the different faces of the rhomboicosted dodecahedron, and so I did. The more I worked with Sonobe units, the more I realized that the individual triangular components butt up against each other in a fairly regular way. In fact, they form a square base. As I played around with this idea more and more, I realized you can make something that looks like this. And I figured, well, this has to be an inverted cube because it looked inverted and I already know that it's related to a cube for 2 reasons. The first is that each of the cavities in my inverted cube maps perfectly to the corner on a regular cube. The second is that if you put my inverted cube in a regular cube, each corner lies on one of the edges of the cube. And so I realized, okay, this has to be my inverted cube. But then I thought about it more and I realized that couldn't make sense. For example, my supposedly inverted cube requires 12 pieces of paper, but a regular cube only requires 6. Additionally, an inverted cube that's made of the same size pieces of paper as a regular cube is almost twice as big. As I thought about it more, I realized this isn't an inverted cube, it's an octahedron. That means it has 8 faces, all of which are triangles. Not only is it an octahedron, it's a concave octahedron, because each of the faces points inwards instead of outwards. So I realized I could probably use Sonobe units to also make a convex octahedron, and so I did, and it looks like this. So I thought more about the relationship between my concave and my convex octahedra, and I realized that if I had any regularly stellated polyhedra, I could turn it into a concave polyhedra. One thing that's very common to do with Sonobe units is to make an icosahedra. That means that it has 20 faces, all of which are triangles. Except that the icosahedra that you would make out of Sonobe units doesn't have flat triangular faces, it's stellated, meaning that the faces are all regular triangular pyramids. So I decided to see if I can make a stellated icosahedra into a concave icosahedra, and it turns out I could. And so this is what I made, and that's what I wanted to share with you today. Thank you for watching.